Hi, welcome back, and this is Stoichiometry Review Part 3. Just to recap, in Part 2, we start looking at the essential steps of a stoichiometry problem, and that information can be found in the top half of the lower left box in your graphic organizer. There are three key steps, depending on the information that you are given and what you're asked to find. And the second step, which is using our mole ratios to convert from moles of given to moles of find, we said that step is always completed in a stoichiometry problem. But steps 1 and 3 depends on what information you're given and what information you're asked to find. You may or may not need those steps. However, if you do need those steps, steps 1 and 3, where you're converting from an amount that's not a mole to moles and vice versa, we use this tool called the mole map. So you fill that out, and we focused on the left half of the mole map, which is the mass and number of particle conversions, and along these arrows here, you wrote down the conversion factors. For example, if you want to go from mass to mole or mole to mass, you use 1 mole is equal to the molar mass. All right, so that's what we looked at. And then you guys did some practice problems in part 2 where you identify what conversion factor you needed depending on the problem. Now we're going to look at is the setup that we typically use for a stoichiometry problem. And that setup is dimensional analysis. So there are a couple of key ideas with a dimensional analysis. For dimensional analysis, you always start by writing whatever your given is over 1. So you write it over 1 just to make it into a fraction. That just makes the math easier. And that's what's shown here. The second thing is that conversion factor that you were practicing identifying that you in video 2, you're going to take that information from the conversion factor and write that into a conversion factor fraction, which is the second one right here. Now, the key thing about this fraction is you want to make sure that the units you don't want, which are the units of your given, cancel out, and the units that you do want, which is your find, you can keep those. And so in order for that to happen, in order for the given units to cancel out, they must be opposite. So essentially always you will find in these problems that the whatever part of your conversion factor that contains the units of your find will go on top or in the numerator of that second fraction, and whatever part of the conversion factor that has the units of your given will go in the denominator or the bottom. And so then you can do that math by multiplying fractions, and then you've got your answer. Okay, so let's take a look at some example problems now, because now what we're going to do is going into solving them. So we're going to look at the same example problems we look in part 1, but now we're actually going to solve them using dimensional analysis. So in this problem, we were given the number of particles, number of C3H8 molecules, and we're asked to determine the number of moles. So that means that we're going from number of particles to moles, so we're using this as our conversion factor. So for our setup, we start with our given. We're given 1.68 times 10 to the 24 C3H8 molecules, and I put that over 1. So always start with that. And then this second fraction here is going to come from this conversion factor. Now, what goes on the top and bottom? So since I'm starting off with number of molecules, I'm going to put the 6.02 times 10 to the 23 molecules on the bottom so that the molecules can cancel out. And then the 1 mole goes on top, and then that gives me my answer, 2.79 moles. Remember, when you're multiplying fractions, you're multiplying straight across. So the 1.68 times 10 to the 24 will multiply with the 1 there. And then in the denominator, 1 times 6.02 times 10 to the 23 multiply together. So the math here would be this number, 1.68 times 10 to the 24 divided by 6.02 times 10 to the 23. Okay, so let's look at another example. In this example, we are given moles, 1.2 moles, and we're asked to find the mass. And so in this case, I'm going to use 1 mole is equal to this molar mass. So 1 mole of NH3 is equal to 17.04 grams. All right, so my given 1.20 moles is over 1, and then in my conversion factor, which I'm going to get from this information here, I put the 1 mole in the bottom so the moles can cancel out, and then the 17.04 grams go on the top, and then I get this value. Okay, and then finally for the last one, this one is actually a two-parter. So I'm starting off with grams and I'm trying to get to number of molecules. So we actually have two conversions we need to do, from grams to moles using the molar mass, and then from moles to number of molecules using what's called Avogadro's number, that's 6.02 times 10 to the 23. All right, so here's my first setup. I take my grams and I multiply it by the conversion factor that involves the molar mass of water. 1 mole on top and 18.02 grams on the bottom, so the grams can cancel out. And that's going to give me the moles of water, but I'm not done yet because what I want to find then is the number of water molecules. So I have a second conversion I need to do in this case. So now that I have moles of water, I want to go from moles to number of water molecules. So for that, I would use the 6.02 times 10 to the 23. I'm going to put that on the top since that's my number of molecules, and I'm put the one mole on the bottom since that's my given, and I want those moles to cancel out there. And then in this case, I get this as my answer. Okay, so what you're going to do now is you have already in part 2 of the practice determined what conversion factors you need. Now you're just going to do that last step of actually solving them using dimensional analysis. All right, so pause the video now and then go back to those problems in part 2 and actually solve them using dimensional analysis.